Have you ever thought about math? Maybe it seems like a subject full of strange symbols and tricky problems. But what if I told you that you already use math every single day? You use it when you decide if you have enough time to walk to the park and back before dinner. You use it when you share a bag of sweets with your friends, making sure everyone gets a fair amount. Math is not just something you learn in a classroom with a teacher pointing at a board. It is a secret superpower that helps you understand the world. It is the hidden language that connects everything around us, from the stars in the sky to the music you listen to. This short journey is designed to unlock that superpower for you. We are going to explore the very basics of math together. There will be no complicated presenter, no confusing jargon, and no tests at the end. Instead, we will look at the simple, beautiful ideas that form the foundation of all mathematics. We will see how these concepts are not just abstract ideas, but are woven into the fabric of our daily lives. From counting your toys to building a sandcastle, math is your helpful companion, making things easier and more fun. Our goal is simple. We want to show you that math is not scary. In fact, it can be incredibly exciting. It is like learning the rules to a new game, one that the whole world is playing. Once you understand the basic rules, you can start to see things in a whole new way. You will notice the patterns in a flower's petals. You will understand how a recipe works. You will even get better at planning your pocket money. This is not about becoming a genius overnight. It is about building confidence and seeing that you are already a mathematician in your own right, navigating your world with skill. So, let's begin this adventure. We will start with the most fundamental tool in our mathematical toolkit: numbers. Long before we had schools or calculators, people needed to count. Imagine you are an ancient shepherd. You have a flock of sheep. How do you know if one is missing at the end of the day? You could make a small scratch on a piece of bone for each sheep that leaves the pen in the morning. As they return at night, you could match each sheep to a scratch. This is one of the earliest forms of a number system. It is a simple one-to-one relationship. One sheep, one mark. As societies grew more complex, people needed better ways to write down larger numbers. Making 50 tally marks for 50 sheep was slow and messy. Ancient civilizations like the Egyptians and Romans came up with their own symbols. The Romans used letters like I for 1, V for 5, and X for 10. This was a huge improvement. It was much easier to write tortue than to draw 12 separate lines. These systems allowed people to record taxes, measure land, and build incredible structures that still stand today. They were creating a language of quantity, a way to communicate about how many without needing the physical objects in front of them. But there was a brilliant idea still missing from these early systems. That idea was the number 0. It seems strange to think of nothing as being an important invention, but it truly changed everything. The concept of 0 as a placeholder was developed in several parts of the world, but it was in India where it was truly perfected. 0 allows us to tell the difference between 3, 30, and 300. Without it, our number system would be incredibly clumsy. Today, we use a system called the Hindu-Arabic numeral system. It consists of just 10 symbols: 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. With these 10 simple digits, we can write any number imaginable, from the number of people in your family to the distance to the moon. This system is powerful because it is a positional system. The value of a digit depends on its position. In the number 252, the first 2 means 200, while the last 2 means just 2. This elegant simplicity is what makes our modern math possible, all built on the ancient human need to count. Now that we have numbers, what can we do with them? The first and most natural thing is to combine them. This is called addition. It is something you do all the time without even thinking about it. Imagine you have 3 red apples in a bowl. Your friend gives you 2 green apples. How many apples do you have in total? You simply put them all together and count. 3 apples plus 2 apples equals 5 apples. Addition is the mathematical way of saying put it all together. It is about finding the total, the sum of everything you have. Addition is everywhere in your daily life, helping you make sense of your world. When you are at the shop, you use addition to figure out the total cost of your items. If a comic book costs £4 and a bar of chocolate costs £1, You add 4 and 1 together to know you need 5 pounds. When you are playing a board game, you add the numbers on the dice to see how many spaces you can move. Addition helps you plan your day, manage your collections, and understand how things grow. It is the first step in using numbers to answer the question, how much in total? The symbol we use for addition is the plus sign, which looks like a small cross. When you see this sign, it is an instruction. It is telling you to combine the numbers on either side of it. So 7 plus 2 is a short way of asking, what is the total if you combine 7 and 2? The answer, which we call the sum, is 9. This simple symbol is a powerful tool. It allows us to write down complex ideas about combining things in a very neat and tidy way. It is a universal instruction that means the same thing to people all over the world, no matter what language they speak. Learning to add is like learning a new superpower. It starts small, with adding single-digit numbers. But soon you can add bigger numbers, like 25 plus 10. You learn that it does not matter which order you add numbers in. 5 plus 3 is the same as 3 plus 5. This is called the commutative property, a fancy name for a simple, useful idea. As you get more confident, you can add long lists of numbers together. This skill is the foundation for so many other things in math. It is the first building block we use to construct a bigger, more detailed understanding of the world around us. After learning to put things together, the next logical step is to learn how to take them apart. This is what we call subtraction. It is the opposite of addition. If you have 5 balloons and 1 pops, how many are left? You started with 5 and you took 1 away, leaving you with 4. Subtraction is the math of how many are left. It is about finding the difference between two numbers. It helps us understand loss, change, and comparison. Every time you spend money or eat some of your snacks, you are using the power of subtraction in the real world. The symbol for subtraction is a small horizontal line called the minus sign. When you see 8 minus 3, it is asking you to start with 8 and take 3 away. The answer, which we call the difference, is 5. Subtraction helps answer important daily questions. If you need 10 minutes to get to school and you have already been walking for 7 minutes, how much longer do you have to walk? You can solve this with subtraction. 10 minus 7 equals 3. You have 3 minutes left. It is also used for comparison. If you are 9 years old and your brother is 6, subtraction tells you the age difference is 3 years. 9 minus 6 equals 3. Unlike addition, the order in which you subtract numbers matters a great deal. Taking 2 away from 8 gives you 6, but you cannot easily take 8 away from 2 in the same way. This makes subtraction a little trickier than addition, but it also reflects how the world works. You cannot spend more money than you have in your pocket. You cannot eat more cookies than are on the plate. Subtraction respects the reality of starting with a certain amount and removing a part of it. It introduces the idea that some operations in math have a specific direction that you must follow. Understanding subtraction is crucial for managing your resources, whether that is your time, your money, or your collection of stickers. It allows you to budget. If you get 20 pounds for your birthday and you spend 12 pounds on a new game, subtraction tells you that you have 8 pounds left. 20 minus 12 equals 8. This helps you make smart choices. Do you have enough left for a movie ticket? Subtraction gives you the answer. It is a practical skill that empowers you to keep track of what you have and what you have used, giving you control over your own world. So, what if you need to add the same number over and over again? Imagine you are buying 4 packs of pencils, and each pack has 5 pencils. You could add them up, 5 plus 5 plus 5 plus 5. That gives you 20 pencils. But, there is a much faster way to do this. This is where multiplication comes in. Multiplication is simply a shortcut for repeated addition. Instead of adding 5 4 times, we can say 4 times 5, which also equals 20. It's a way to make calculations with groups of things incredibly quick and efficient. We use the times sign, that's the little x, to show multiplication. So, 4 times 5 equals 20 is the mathematical way to write 4 groups of 5 make 20. This simple idea helps us solve bigger problems with ease. For example, if a school bus has 10 rows of seats and each row can fit 4 children, how many children can fit on the bus? Instead of adding 4 10 times, we can just multiply 10 times 4 to get 40. Multiplication is essential for scaling things up. It helps us understand how small groups combine to make very large totals, from counting bricks in a wall to calculating the number of days in several years. Multiplication is all around you, often hidden in plain sight. When you see tiles on a floor arranged in a neat grid of rows and columns, that is a multiplication problem. A grid of 6 rows and 10 columns has 6 times 10 equals 60 tiles. When you bake cookies and arrange them on a tray in 3 rows of 4, you have 3 times 4 equals 12 cookies. This visual arrangement is called an array, and it's a fantastic way to see what multiplication really means. It's not just an abstract calculation, it's a way of organizing and counting objects in the real world efficiently. Learning your multiplication tables, or times tables, is a rite of passage for many students. It might seem like a lot of memorization, but it's actually about recognizing patterns. Once you know them, you unlock a new level of mathematical fluency. You can solve problems much faster, which gives you more brain power to tackle more interesting challenges. Multiplication is a fundamental building block for more advanced math, like calculating the area of a room or understanding percentages. It's the tool that lets our calculations grow, helping us think big and solve problems on a much grander scale. After we have learned to multiply, it is time to learn how to do the reverse. This is called division. Division is all about splitting a total amount into equal groups. It is the mathematics of sharing and fairness. If you have 12 sweets and you want to share them equally among 3 friends, how many sweets does each friend get? Division helps you figure this out. You would divide 12 by 3 and find that each friend gets 4 sweets. It ensures that everything is distributed fairly, which is a very important concept in both math and life. The symbol for division is a line with a dot above and below it. So, 12 divided by 3 equals 4 is the mathematical sentence for our sweet sharing problem. Division answers the question, how many in each group? Or how many groups can you make? For example, if you have 20 photos and you want to put 4 photos on each page of an album, how many pages will you need? You would calculate 20 divided by 4, which equals 5. You will need 5 pages. Division helps us organize things into manageable portions, whether we are cutting a pizza into slices or figuring out how many cars are needed for a group trip. Sometimes things do not divide perfectly. What if you have 13 sweets to share among 3 friends? You can give each friend 4 sweets, but you will have 1 sweet left over. This leftover part is called the remainder. The concept of remainders is very important because it reflects the reality that things in the world do not always fit into neat, perfect boxes. Understanding remainders helps us solve problems more realistically. It teaches us that sometimes there is a little bit left over after we have shared everything out as fairly as possible. Division is the final of the 4 basic operations, and it ties everything together. It is the inverse of multiplication, just as subtraction is the inverse of addition. If you know that 4 times 3 is 12, then you also know that 12 divided by 3 is 4. They are 2 sides of the same coin. This network of connections between addition, subtraction, multiplication, and division forms the core of arithmetic. Mastering these 4 operations gives you a powerful set of tools to analyze situations, solve problems, and make fair and logical decisions in countless everyday situations. Math is not just about numbers and counting. It is also about the space we live in and the shapes that fill it. This branch of math is called geometry. Look around you right now. The screen you are reading this on is likely a rectangle. The plate you eat from is probably a circle. The room you are in is a cuboid, which is a 3-dimensional shape made of rectangles. Geometry is the study of these shapes, their sizes, their positions, and the properties of space. You have been an expert in practical geometry since you were a baby, figuring out how to fit a square block into a square hole. We can start with the simplest shapes. A square has 4 equal sides and 4 perfect corners. A rectangle is like a stretched-out square with 2 pairs of equal sides. A triangle has 3 sides, and they can come in all sorts of different arrangements, from long and skinny to perfectly balanced. A circle is a perfectly round shape where every point on its edge is the same distance from the center. These are what we call 2-dimensional, or 2D shapes. They are flat, like a drawing on a piece of paper. We see them everywhere, in flags, in road signs, and in the patterns on our clothes. but we live in a three-dimensional or 3D world. This means our shapes have depth. A cube, like a dice, is a three-dimensional shape made from 6 square faces. A sphere, like a ball, is a perfectly round three-dimensional shape. A pyramid has a flat base and triangular sides that meet at a point on top. Understanding these 3D shapes is incredibly important. Architects use them to design buildings. Engineers use them to build cars and bridges. Even when you are packing a suitcase, you are using your intuitive understanding of 3D geometry to fit everything in as efficiently as possible. Geometry is also about understanding the relationships between shapes and space. It helps us understand concepts like position, direction, and movement. When you give someone directions, you are using geometry. Go straight, then turn left at the big tree. It is about understanding angles, knowing the difference between a sharp turn and a wide turn. It helps us appreciate the symmetry in a butterfly's wings or a snowflake's design. Geometry is the visual side of mathematics. It gives us the language to describe the beautiful and orderly structure of the physical world we inhabit. How do we use numbers to describe the world? We use them to measure things. Measurement is the process of assigning a number to a characteristic of an object or event, so we can compare it with other objects or events. The most common things we measure are length, weight, and time. These measurements help us bring order to our world. They allow us to answer practical questions like, is this box too big to fit through the door? Or do I have enough time to finish my homework before my favorite show starts? Without measurement, our world would be a very confusing place. Let's start with length. Length tells us how long, how wide, or how tall something is. We use tools like rulers and tape measures to find it. We use units like centimeters, meters, and kilometers. Knowing that your friend's house is 1 kilometer away gives you a much better idea of the journey than just being told it is far. Measurement of length is vital for everything from buying the right size shoes to building a house where all the walls fit together perfectly. It allows us to be precise and to create things that work correctly in the real world. Next, we measure weight, or more accurately, mass. This tells us how heavy something is. We use scales to measure weight, and the units we use are often grams and kilograms. When you are baking a cake, the recipe will tell you to use a specific weight of flour and sugar. This precision is what makes the cake turn out delicious every time. We use weight at the grocery store to determine the price of fruits and vegetables. Understanding weight helps us know if a backpack is too heavy to carry, or if a bridge is strong enough to hold the cars that drive over it. Finally, one of the most important things we measure is time. Time tells us the duration of an event or the moment it occurs. We measure time with clocks and calendars, using units like seconds, minutes, hours, days, and years. We schedule our lives around time. We use it to know when to wake up, when to go to school, and when to meet our friends. Time helps us understand sequences of events and plan for the future. These 3 types of measurement, length, weight, and time, are fundamental skills that allow us to interact with our environment in a meaningful and organized way. One of the most beautiful things about math is its love of patterns. A pattern is something that repeats in a logical, predictable way. You can find patterns in numbers like the sequence 2, 4, 6, 8. What comes next? It is 10, of course, because the pattern is to add 2 each time. You can find patterns in shapes like the repeating design of tiles on a floor square, triangle, square, triangle. Spotting these patterns is a key mathematical skill. It is like being a detective, looking for clues that reveal the underlying structure of a problem. Why are patterns so important? Because they help us make predictions. If you notice that the bus arrives at your stop every 10 minutes, you can predict when the next one will come. Scientists use patterns in data to predict the weather. Doctors look for patterns in symptoms to diagnose an illness. The world is full of complex information, and finding the patterns within it is how we make sense of it all. It turns chaos into order. Learning to recognize patterns in math trains your brain to look for them everywhere else, making you a better problem solver in all areas of your life. All of the math we have talked about, from counting and shapes to measuring and patterns, is interconnected. They are not separate subjects, but different tools in the same toolkit. You use addition to help with multiplication. You use your understanding of shapes to help you measure the area of a room. This interconnectedness is what makes math so powerful. It is a logical system where each new idea is built firmly on the ones that came before it. By learning the basics, you are not just memorizing facts. You are building a strong foundation for a lifetime of clear thinking. So, why does math matter? It matters because it is the language of logic and reason. It trains your mind to think clearly and solve problems step by step. It gives you the confidence to face challenges, break them down into smaller parts, and find a solution. Whether you become a scientist, an artist, a chef, or a parent, a basic understanding of math will help you every single day. It helps you manage your money, follow a recipe, or simply win your next board game. Math is not just for mathematicians. It is a fundamental human skill, a secret superpower that belongs to everyone. And now it belongs to you.